Once we explained the idea behind data abstraction, which was an idea that actually arose in the early 80s of the previous century, very quickly the object-oriented programming paradigm came along. And then we got this paradigm that deals with how to identify objects, how to have them communicate with each other, right? How to design systems based on the communication between objects, and all that is what's known as object-oriented programming, object-oriented design, object-oriented analysis. All that is all, in a sense, implementations of this idea of data abstraction, which is not the same thing like procedural abstraction, which is functions, which is not the same thing like imperative programming, which you tell the program how to do something. Notice we're talking about implementation. When we talk about imperative programming, we are talking about how to get the state of the system from one place to another. That's how we talk when we talk about imperative programming. We talk about how to get the data. The data there in imperative program is just glue to go between one line to the next. It's just, okay, I have a piece of data here, I need it over there. How do I move from here to there? Oh, I create some kind of variable, I stick it there for a while, and I take it out when I need it. So imperative programming, the data is just helper in the how to do something. As opposed to data, the object-oriented paradigm, data is king. And when I say data is king, I mean to say is that the entire paradigm is built upon the connections between data. How do data connect to each other? What is data? What is data representing? And not how it's implemented. Obviously, at the end, everything has to be implemented somehow, and we have to deal with the nitty-gritty, so we have to go sit down and program it. That's obvious. But when we talk about object-oriented paradigm, we are talking about the objects and the connections between them, and not how to move the program from state to state.